Section 5, we're going to look into what's known as the binomial theorem. What the binomial theorem is going to allow us to do is take binomials, okay, such as x plus y, and raise them to some power. Okay, so like x plus y to the fourth. Right now, the only way that we could go about doing that would be to expand it out and multiply, say, these first two together, and then maybe the third and fourth together, but then we'd have to do all this multiple distribution, and it's a long process, and it's kind of a pain, a lot of places where we can make mistakes. Now, one of the methods that we can use to multiply these out is what's called Pascal's triangle. If you look at Pascal's triangle, what it does, it starts up here with 1, and each edge of my triangle, the outside edges, they're all 1s. Okay, and so from there, how we build into it and get the missing terms is what I'm going to do is there's a mini triangle in here. And the point is down, and what we do is we take the 2 on the top of it and add it together. So 1 plus 1 gave me 2. This mini triangle right here, 1 plus 2 gives me 3. Okay. If I go create another one here, 6 and 4 gives me 10. And they're going to come into play when we start looking at one of the ways we can go about expanding out these binomials raised to a power. Okay. So if we think about what's going on here, if I take x plus y and raise it to the 0 power, yeah, we know anything raised to the 0 power is 1. Okay. But if we include the x and the y, the way that we can make them be equal to 1 is by raising each of those to the 0 power again. So now what you have is x to the 0, which is 1, y to the 0, which is 1, 1 times 1 times 1 gives me 1. X plus y, all raised to the first power. Well, again, anything raised to the first power is simply itself. Okay, so x plus y. So if I include the x and y again, well, if I go into this first term here, this x, I'm missing the y piece. Well, how can I put that y piece in there? Well, I can put it in there if it's 1. Okay, how do I make it 1? Y equals 0. Same thing with the second part. I want to put the x in. How can I do that? Each coefficient in this case is 1 as well. Okay. You may start recognizing a couple things from our triangle. Here was your x plus y to the 0. Here's your x plus y to the first, in terms of if I look at the coefficients. Okay. If I continue on, and I go with x plus y, that quantity squared. So now, like I said earlier, what we could do is take x plus y times itself, FOIL, double distribute, and what we're used to seeing is simply x squared, okay, plus 2 times x times y plus y squared. But again, if I bring in that y into that first term by using y to the 0, okay, and then they were both in the middle term, okay, and then I got to introduce the x into the last term. Look at my coefficients this time. 1, 2, 1. 1, 2, 1. Okay. Now, if we kept going, x cubed and did the same things. Okay, and what I'm really doing is taking this expression up here times x plus y again, so I distributed the x through, and then I distributed the y through, combined some like terms. But again, 1, 2, 2, 1. Actually, these should be 3's. My apologies. Okay. And they match up with these. Now, the other pattern to look at is we want to look at the exponents. When I started out, x is to the third, okay, y is to the 0. Okay. Now, x started out as the third power because that was my first term. As I worked my way down, now x got smaller by 1, y got bigger by 1. X gets smaller by 1, y gets bigger by 1. X gets smaller by 1, y gets bigger by 1, and then again, look at what we ended up with. So how this is going to work for us. If I want to expand x plus y to the 6th power, okay, what I'm going to do is first pull my triangle over here. Okay, make some connections here. I'm going to go down here where it was the 2nd power. It wasn't the 2nd row, but it's where if I look at this 2nd diagonal or 2nd edge here, it's where that term was 2, 3. That's where I use my coefficient. So now when I get here, I want to use the row where my 2nd term is 6. Okay? Well, I don't have it, so I'm going to add it in. Okay? So again, the outsides are always 1s. Add 2 successive to get the one that drops down in between it. Okay. So this would be the row that I'm going to use from Pascal's triangle. Okay. So that's how I'm going to go about starting this out. Okay. I'm going to go in and write down my coefficients. 1, leave space, 6, 15, 20, 15, 6, and 1. Now, what I'm going to do is take my first piece of my binomial x. And if you look back again, okay, the first piece got raised to the power that we're raising it to at the beginning. So my first piece x is going to get raised to the 6th power of my first term. Then I went down 5, 4, 3, 2, 1, 0. Okay, we should always be able to get back to 0. If I came up something not 0, okay, either I started at the wrong spot, okay, or goof somewhere. Now, going the other way, if you think about what happened with my y, my 2nd term, it started at 0 and built up to the power that we were looking at. Okay, so it built up to, in this case, the 6th power. Okay, so I'm going to start y to the 0. 1, 2, 3, 4, 5, 6. Another interesting fact, if you add those exponents together, you're always going to get 6. Okay, now what I want to do is simplify each of those. Okay, so 1 times x to the 6, again, this goes to, y to the 0 goes to 1. Plus 6x to the 5th y, plus 15x to the 4th y squared, plus 20x cubed, y cubed, and so on and so forth. And when we get down here to that last one, remember x to the 0 goes to 1, so we're just left with y to the 6th. A little bit of work, but think about if you were going to go in and take the x plus y times itself 6 times. A lot more work. Okay. All right. All right. Let's say we looked at something like this, x minus 2y, and we want to expand that to the 4th power. Okay. It's going to be a similar process. There's the row I want to use. So 1, 4, 6, 4, 1. Okay. Same idea. I'm going to start with that first piece of my binomial to the power of my binomial, x to the 4th, work my way down, x cubed, squared, first, 0. Now, difference here is on the previous problem it was just plus y. Now it's a negative 2y. What I have to do is that I'm going to take negative 2y, not just y here, to the 0 power. Then negative 2y to the 1st, negative 2y to the 2nd, negative 2y cubed, negative 2y to the 4th. I'm not just raising the variable to the power. I have to take that whole expression. In this case, we actually have to include as well the sign, the negative. And so now when I simplify it, it might take me a couple steps, because now I have 1 times x to the 4th. Well, this one's nice because it just goes to 1 again, so I get x to the 4th. Here I have 4x cubed. Now, raising to the first power, negative 2 gets raised to the first, and y gets raised to the first. So the 4 and the negative 2 become negative 8, x cubed y. 6, x squared. Now, this time negative 2 squared becomes positive 4, y squared. So since when I take 4 times 6, I get positive 24. It's a plus. Okay. This becomes negative 8, y cubed. Okay. This becomes positive 16, y to the 4th. And done. Okay. So yes, it's a little bit of work once in a while in terms of getting your triangle set up and getting your exponents, but it's a lot easier, I think, than multiplying. In the next video, we're going to look at yet another method we can use to multiply these out a little quicker.